Okay, good. So part 4 is to calculate the number of neutrons in the second isotope. So here we are, the second isotope. We know how many protons it's got now, 92. And what we're trying to find is the number of neutrons. It's a 3-mark question here. So we know that we're going to have to do a little bit of calculation, a bit of thinking. So this was part 3. Let's go to a lighter color, shall we? This is part 4. In fact, let's do that in a different color. Let's do it in pink. Let's do it in ninja pink. There we are. Okay. What do we know? Always a good place to start with questions. We know that we have got a specific charge of 3.7 times 10 to the 7. So, specific charge equals 3.7 times 10 to the 7 times 10 to the 7 coulombs per kilogram. And by the way, take a look at the previous answer that we got, and we can see, oh look, that agrees quite nicely with that, even though that's slightly higher specific charge because the isotope has got probably a few less neutrons, but we'll see how we go. So that means we've got confidence in that previous answer. So specific charge is that for the second isotope. What else do we know? Well, we know it's got 92. We know that it's got 92 protons, so Z equals 92 protons. And remember that specific charge is the charge divided by the mass. And remember that we found what the mass was by adding up the atomic number with the number of neutrons. That gave us the nucleon number. So we know what the charge is because that's going to be the same as this chap here, because we've got 92 protons. So we know what that is. And therefore we can find out what the mass is from this equation. And if we can find out what the mass is, then we can subtract the mass of 92 protons. Or in fact, better still, there's a better way of getting that. We can work out we can divide by the mass per nucleon, and that will give us the number of nucleons, and then we just simply take away the 92 from that. I'll take you through. First, let's give ourselves a bit of room here. This is the next question, but I'm just going to pop this down a little bit. Give us a bit of room. Okay, right, here we go. So, we know that the charge from the above question is 1.47 times 10 to the minus 17 coulombs. And let's find out what the mass is. So mass is what we're looking for, let's say, for the moment. Question mark. So mass is equal to specific is its charge, just rearranging that equation over specific, I'm going to call it spec charge, there we are. And let's put the numbers in there. So we're going to get 1.47 times 10 to the minus 17 divided by 3.7 times 10 to the 7. To check the units, yes, they agree, they're all good. And that's going to give us a quick calculator moment. 1.47 times 10 to the minus 17 divided by 3.7 times 10 to the 7. And we're going to get a mass of 3.97 times 10 to the minus 25. And by the way, specific significant figures, I'm going to 3 significant figures just in the calculation. The rule of thumb is that we should only go to the same number of significant figures for our final answer as for the smallest number of significant figures in the question, and we'll do that right at the end, but for the moment let's keep an extra one in there for accuracy to avoid rounding errors. So we now know that that's 3.97 times 10 to the minus 25. What is the unit? It's kilograms. Okay, so now we know what the mass is of all of the nucleons. So let's take that mass and let's divide it by 3.97 times 10 to the minus 25. And let's divide it by the mass of each nucleon. And that should tell us how many nucleons we got. Does that make sense? What is the mass per nucleon? Well, up here, we said that each proton and neutron has a mass of 1.67 approximately. They are slightly different, but that's pretty much exactly right there for three significant figures. Times 10 to the minus 27 kilograms. So let's divide that. 1.67 times 10 to the minus 27. And that should give us the number of, that should give us the nucleon number. The nucleon number, that should be A, because that will be the total number of things, of nucleons in the nucleus. So let's try that. Divide by 1.67 times 10 to the minus 27, and we get 237.9. Now hang on a minute, you can't get 0.9 of a nucleon, so what we have to do here is round to the nearest, and that's going to be, that error has crept in due to probably the significant figures here, so that's okay to do that. 238 nucleons, and this is known as uranium-238, funnily enough. Uranium-238. So the number of nucleons, you got it, is number of neutrons, sorry, you got it, is that number, which is the mass number or nucleon number. Just squeeze it in here, 238. Subtract 92 from it. There we go, and we're going to get 611. So that's 146 neutrons. Ta-da! Okay, so 3-mark question, and 146 neutrons in there. Hope that made sense. Just working it through. Whenever you do questions, it's very, very important to first of all start off writing down what you know. Because if you're not sure how to start, that will give you clues on what equation to select and then the path to solve the question. Next question. Okay, along the same lines now, find the specific charge of the nucleus of an atom of carbon. Here it is, 12, 6. So it's carbon 12. It has 6 protons. It has 12 nucleons. So therefore, guess what? It's got 6 neutrons. So specific charge, again, that name's specific. And let's work that out. In fact, I'll use that color here. Okay, so how would we proceed? Well, what we're looking for is specific charge, and that is charge divided by mass. We know what the charge is of this. It's got 6 protons, so it'll be 6 times 1.6 times 10 to the minus 19, because that's the coulombs per proton. By the way, that's also the charge on an electron, except it's negative, of course. Divided by, now how many things have we got in this nucleus? We've got 12 things, so it's going to be 12 times by. Now notice that they've given us some different numbers here, so I guess really we ought to use the separate numbers for the protons and the neutrons. They're very close, but so let's actually do that. I'll be good today. Here we go. So we've got 6 protons, so we're going to put this in brackets. 6 times 1.6726 times 10 to the minus 27 plus 6 times 1.6749 times 10 to the minus 27. Oh, bit of a mouthful there. That I guess should all be in a big square bracket underneath. And that's a 3-mark question, but let's just move that out of the way. Oh, look, there's a hole in the middle. Oh, no, we better put it back. Okay, no worries. Let's take a look underneath there. So doing that, popping that in the calculator, probably best to do this part first, by the way. The underneath first. So let's just do that. 6 times by 1.6726. 1.6726 times 10 to the minus 27. Okay, plus open bracket 6 times 1.6749 times 10 to the minus 27. Close bracket equals. So that is 2.0085. Better go to the same significant figures they're going to here for the moment, times 10 to the minus 26. Minus 26. So putting it all together, divided by 6 times. Actually, if I was clever, I could have actually cancelled that 6 there with both of those, and that would have been a lot easier, wouldn't it? Oh well, we'll carry on for the moment. 6 times by 1.6 times 10 to the minus 19 equals that. Okay, so what we get is a specific charge of 47.8, and I'm only going to go to 3 significant figures here. They've only given us 2 significant figures for the electron charge, so really we should only go to 2 significant figures, but 3 is fine. 1 more is usually safe. Times 10 to the 6 coulombs per kilogram. There we go. So simple, specific charge calculation. Do make sure you write out the numbers. You can always see how you can simplify things. I should have simplified the 6, factor of 6 on the top numerator and the denominator. Do the complicated things first so you can actually check to see if it's right. Don't just plug it all in the calculator. That's where mistakes happen. So step by step. Does that make sense? 47.8. Well, remember the uranium case? The uranium specific charge was 3.7 times 10 to the 7. So we're around the same kind of ballpark, aren't we? In fact, yeah, because that's 4.78 times 10 to the 7. So that makes sense. Okay. All right, I may be out of time here. Let's just check how we're doing. Now, probably just room for one more, maybe? No, I'll split this into another video. I'll see you in the next one.